Hello everyone. So today we're going to work on classwork 6.6, which is area of a sector. So we did the length of an arc, and now we're going to look at the area kind of like of a pizza slice. So looking at the area of a specific sector. Let me go ahead and share all this with you, and let's get going. Okay. So area of a sector. Area of a circle, let's start with that. The product of pi and the square of the radius. So area of a circle is equal to pi r squared. Let's practice that. I know you guys have done this a ton of times, but just for practice. What is the area of the circular region on the wrestling mat? Well, the diameter, the full length across is 32 feet. So the radius would be 16. We do A equals r squared, which is 16 squared pi. A would equal 16 squared is 256 pi. That's an exact answer, but if we want the rounded answer, we could do that in our calculators, which is 256 times, not e, but pi, and we would get 804.25. 804.25 feet. So that's the area of the whole mat, and this is going to be feet squared because it's area. Area is always in square feet. So now that we've done that, what if we wanted just half of this or a portion of this? We want a sector of a circle, the region bound by an arc of the circle and the two radii that meet at the endpoints of the arc. It is named by using one endpoint, the center of the circle, and the other endpoint. So like this is sector RPS because it is encompassing that circle or that shaded area right there. Generally, it is going to show a shaded area. So the area of a sector in radians is going to be pi r squared times theta over 2 pi. And then in degrees, it's going to look almost exactly the same, pi r squared, but this time it's theta over 360. Now we're going to do the degree one today because I want some practice with that. We practiced with radians yesterday. Today we're going to do some practice with degrees. So, and this one you can do in degrees. Like, I know length of a sector, it had to be in radians first before we did. That's why I gave you either or option. So let's do the example. Find the area of the sector, which is, like I said, generally shaded with the given circle below, given an exact and a rounded area, answer. Okay, so we have A equals pi 15 squared times 72 over 360. So let's do that in here. We're not going to, because it's an exact answer first, we're not going to worry about the pi. We'll do 15 squared times 72 divided by 360. And we get 45 for that answer. Right there, you can see 45. So here I would have 45 pi, and this is in centimeters squared. But if I wanted to get an exact rounded answer, I guess not exact, and a rounded answer, it would be 45 times pi, which is 141.37. We're going to round to the nearest hundredth. So 141.37 centimeters squared, which means this portion of the circle right here is 141.3 centimeters squared. That's the area. I'm going to double check this by doing 15 squared times pi. That would be the area of the whole circle, and it should be bigger. And it is. It is significantly bigger. So the area of the whole circle is bigger. Let's look at the next one. The area of sector AOB, this is the shaded area here, in the following image is 28 pi centimeters squared. So that's the area already. Find the measurement of the central angle labeled x degrees. And since it's in degrees, we'll be working with degrees. So I have 28 pi, because that's the area, is equal to the radius squared times pi r squared. I know I kind of flip those around, but that's totally fine. Times whatever the angle is over 360. So here we can divide both sides by pi. 12 squared is 144 times x over 360. I can divide by 144. So 28 divided by 144 is a repeating decimal, so I'm going to make it into a fraction. It's 736. So 736 equals x over 360. We'll multiply both sides by 360. I think this is going to come out to 70. We'll see in a second. 360 times 7 divided by 36, we get 70. And I knew that because 36 was going to cancel out. There's still 10 here. 10 times 7 is 70. So 70 degrees equals x. Okay. And the last question. Circle O has a minor arc, minor being less than 180, AB. So let's draw this. We have circle O, a minor arc, AB, with an angle measure of 60 degrees. So this is 60 degrees. It's not drawn to scale. Sector AOB has an area, so A equals 24 pi. What is the radius? So we need to find the radius. That's the unknown, x. All right, so 24 pi is equal to pi r squared, so pi r squared, and then 60 over 360. Pi's cancel out. 24 is equal to r squared, and 60 over 360 reduces to 1/6. Get rid of the 1/6, so we're going to multiply by 6. We get 144 is equal to r squared. Take the square root of both sides, and r is equal to 12. And we're talking about, they don't have it, so we're going to say units. 12 units. We don't know what the measurement is. Okay. So by the time we get to this point, I'd really suggest pausing the video and trying this yourself. This is combining what we learned yesterday with what we're learning today. So not only are you finding the length of the arc, but you're also finding the area of the shaded region. Round the answer to 2 decimal places. You can use 3.14. I'm going to use pi in my calculator. It's up to you. And we're going to use our equation from yesterday, which was length is equal to, hopefully you remember this, length is equal to r theta. And then we're going to use today's, which is A is equal to pi r squared theta. All of these are in degrees, so we're going to do theta over 360. Now, the big thing with all of that is I have to change this into radians to do all the lengths. So make sure you remember that. So I'm going to start going through and doing that. So we have theta times, remember, pi over 180 is how we're going to change it. So 270 times pi over 180. 270 over 180 is 3 halves. So it'll be 3 pi over 2. And then down here I'll do my work. Length is equal to r, which is 12 times 3 pi over 2. And my area is equal to pi r squared, which is 12 squared or 144. You can put 12 squared or 144 times my theta, 270 over 360. So let's put these in. We have 12 parentheses 3 pi divided by 2. So my length is 56.55 inches. And for my next one, it's pi 12 squared times 270 divided by 360. If you put 3/4 in there, that's fine too. That's what it is. It's 339.29. 339.29 inches squared. And that's what we're doing for this. We're just going to plug and chug. It really helps to have these memorized, just to help you guys out. So for here, it's 65 times pi over 180. 65 divided by 180. Math, enter, reduces to 13 over 36. So it's 13 pi over 36. Okay, so length is going to be equal to 17 times 13 pi over 36. And the area is going to be equal to pi 17 squared times 65 over 360. Let's put these into the calculator. 17, sorry, I should show you guys the calculator. 13 pi divided by 36. And we get 19.29. So this time we're talking about centimeters. And for the next one, it's going to be pi 17 squared, 65 divided by 360. And I get 163.93. 163.93 centimeters squared. Okay. Well, let's keep going. Length of the arc of EF, so we have 240 times pi over 180. That's going to equal, there's 4 pi over 3. I'm going to double check that real quick. 240 divided by 180 is 4 pi over 3, yep. Okay. And then so we have length is equal to 9 times 4 pi over 3. And my area is equal to pi 9 squared times 240 over 360. Let's look at what this is. 9, 4 pi divided by 3. We get 36.70. This is meters. And for the next one, we get pi 9 squared 240 divided by 360. And we get 169.65 meters squared. We're going to do 2 more of these together. If you want to do more, you're more than welcome to, but we're only going to do 2 more together. All right, so looking at the next one, we have 160 times pi over 180. This comes out to 8/9. So 8 pi over 9. The length is equal to 20 times 8 pi over 9. And my area is equal to pi 20 squared 160 divided by 360. Let's plug that in. So 28 pi divided by 9, 55.85 feet. If you're wondering where I'm getting those units from, just getting them from the problem. And then the next one is pi 20 squared 160 divided by 360. Sorry, that was times 160 divided by 360, which is 558.51. 558.51 feet squared. And if you decided to use 3.14, your numbers might be a little bit off for me, but they should generally be around those same whole numbers. It's okay if they're a little bit off. And for the last one we're going to do together, this is 40 times pi over 180, which is going to give us 2 pi over 9. Everybody's okay with that? 2 pi over 9. And then we have the length is equal to 5 times 2 pi over 9. And the area is equal to pi 5 squared times 40 over 360. Okay. So 2 pi divided by 9 gives me 3.49. 3.49 meters. Okay, and then the other one is pi 5 squared 40 divided by 360, which is 8.73. If you guys want to practice the rest of these, you're more than welcome to, but you do not have to. All right, you guys are going to have 6 problems for your homework tonight. Yep, just 6 problems. I know you guys are more than capable of getting it done. I hope you have a wonderful day, and I will talk to you later.